Assalamu alaikum. Dear students, today we are going to discuss this question, Winter 22, question paper 2-1, question 3, D part. Okay, in this question, actually they are saying when sulfur, which is S8 molecule, reacts with chlorine to form several different chlorides. The most common are S2Cl2 and SCl2. SCl2 forms when sulfur reacts with excess of chlorine. So these two reactions are given here. So first reaction shows that when sulfur reacts with 4 chlorine molecules, it is giving us 4 moles of S2Cl2. Similarly, reaction 2, this S2Cl2 gives a reaction with chlorine and the product is 2 moles of SCl2. So in this part they are saying it is a cherry red liquid. So that is important information which we are getting from this question, that reacts vigorously with water to form an acidic solution. So they are saying use this information to deduce the bonding and structure shown by SCl2. So first of all, sulfur is in group 6. Okay, so that is definitely the oxygen family, right? Okay, now here this hint indicates that sulfur must be, this molecule SCl2 must be a simple molecule, and if simple molecule, so its structure, as you can see here, sulfur has 6 electrons in its outermost shell. So 6 electrons in valence shell, and out of these 6 electrons, 2 are being used up in covalent bonding with the chlorine atoms, and there are 2 pairs of electrons which are not involved. I would call them lone pair. So it looks like exactly the same as we can see in case of water. But the difference here is oxygen is being more electronegative, carries partial negative charge, and hydrogen partial positive charge. But same type of bonding and band structure because of 2 lone pairs, as we have discussed in valence shell electron pair repulsion theory, that in determination of the geometry, these lone pairs repulsion is greater than the bond pair, so due to which its structure is band structure. So same is the case here. Due to these lone pairs, there will be a repulsion, greater repulsion by the lone pairs, and we get the bent shape of this molecule. So due to greater electronegativity, as we know that chlorine is in the next group, which is group 7, and it is more electronegative, so that's why due to greater electronegativity it carries partial negative charge. So there will be a permanent dipole forces, so which are definitely stronger than simple van der Waals forces. So permanent dipole forces. So due to this reason, it is having a lower melting point and boiling point, and it exists as liquid, as they have given us the hint in the question that it is a liquid and it reacts with the water, which means it is hydrolyzed. So it is hydrolyzed, so that indicates the covalent bonding, as we can see from the structure. So if they ask about the bonding, so there is covalent bond between the sulfur and chlorine atoms, and if they ask about the structure. It's a bent structure, covalent bonding and liquid. So that means simple covalent molecule. Now the next part of this question is this. They are saying calculate the enthalpy change of formation of SCl2. You may find it useful to use the Hess's law to construct an energy cycle. Now here these two reactions are given. So if we look at this reaction 2, so we can see S2Cl2 liquid when reacts with chlorine, it gives us 2SCl2, and the enthalpy change of this reaction is minus 40.6. Okay, if we look at this reaction, we can solve it by making the Hess's cycle, sorry. So if I take sulfur in the standard state as 8 molecule and chlorine Cl2 in the standard state, the gas form, I would better write it like this, S8 solid. So it is a standard state of sulfur and standard state of chlorine. So if we make the Hess's cycle, so I can say that if sulfur and chlorine, when they react, they will give us S2Cl2. And sulfur and chlorine when reacts, you can see it is giving us S2Cl2. Its value is given here, but the question is, here 4 moles of S2Cl2 are produced. So if I write down here minus 58.2 kilojoules, so that is basically the delta HR. So my product will be 4 moles of S2Cl2. But in the next equation, as you can see, 1 mole of S2Cl2 reacts with 1 mole of chlorine. But I am getting 4 moles of S2Cl2 from my reaction 1. And the enthalpy change in that is minus 58.2. So if I get 4 moles, so I have to balance this equation, and to balance it, I would have to multiply this Cl2 with the 4, and I will also have to multiply this 40.6, the enthalpy change, with the 4 as well. And if I multiply this 2 with the 4, so definitely I will get 8 moles of SCl2. Now, if you look at this, when sulfur and chlorine reacts, they will give us SCl2, but now you can see there are 8 moles of SCl2 which are being produced, so that would be my delta H formation multiplied by 8, because I am getting 4 moles of 8 moles of SCl2. Now if I apply this Hess's cycle, and according to the Hess's law, I can calculate the delta H formation. So let's put the values here. So you can see minus 58.2 plus 4 times minus 40.6, that will be equal to this one, that is 8 times delta H formation. Now minus 58.2, and if I multiply this 40.6 with the 4, so I will get 40.6 times 4, 162.4 delta HF. And if I add this one, I will get 220.6, is equal to delta HF. And now if I want delta HF, I have to divide this value with 8. So by dividing this by 8, the answer is minus 27.575, which is the delta H formation. So if I simply round it off, so answer will be minus 27.6. So that's how we can solve this type of question. So there is another way by which you can solve it. If you just uh, divide this 58.2 by 4, you will get the delta H formation of S2Cl2, and there will not be any need to multiply this whole equation by 4. If you want to keep this equation same, you have to divide this 58.2 by 4, so you will get the delta H formation of S2Cl2. So that's in this way, by using the Hess's law, we can calculate the delta H formation of SCl2. Hopefully you got the idea. Thank you.